Now that we've created our first VI that turns the motors on, waits 1 second, and stops, we'll talk about modifying it. First, it's important to know what the defaults are for the different functions. Since we've not modified any of them, we're going to be operating under these defaults. For the motor move, the power is set at 75 on a -100 to 100 scale. And second, it is set to do all motors. That is, when you just add the motor move function, it moves all motors simultaneously. For the wait function, the default is 1 second. That can be changed from anything from a fraction of a second upwards. And then finally, the default for the brake, similar to the motors on, it is all the motors. So the way that we modify these is by actually wiring in modifiers that change the defaults. So for the turn motors on function, instead of a default of 75, we could wire in a 25. This would move that motor slower than the default 75. Second, we could specify that we actually just want port A. So instead of moving all motors, just move the motor on connected to port A. For the time, you can change that as well by modifying it instead of just 1 second to, for instance, be 2 seconds. And then for the brake, instead of moving all motors, we can also move just port A, either by wiring in a new port A, or we can use this wire and connect it up as well. This allows you to easily change the code in just one place, but affect multiple modifications. The second thing that we'll show is that you can also copy and paste your code to duplicate it and increase your program. So here what we'll do is we'll increase the start motors. We will do a second wait for time, and then finally a second brake. But this time, instead of port A, we can change it to, say, port D and control a second motor instead, and perhaps do that for 3 seconds instead of 2. And if we copy the code, there'll still be the 25 there for the power. All right, so let's look at what this modified VI looks like in LabVIEW. Since I previously had done some programming, I have my first VI saved here. If I double click that, it will open that existing program. By default, it opens up the front panel, and you might be wondering where your code went. Remember, this is the front panel. Your code is located on the block diagram. If you go up to Window, you can show block diagram. The shortcut there is Command E. Clicking Show Block Diagram pops this open. We are here in the main application instance, and so I have here my EV3 tethered connected up to my computer. You see, I've labeled my two motors as A and D, and we're going to run this program using the defaults. The defaults are to run it at power 75 pretty fast, and run all motors, wait 1 second, and then stop. I'll select the run button here in the top left, and we'll watch the motors move. So they both moved for 1 second, both motors A and D. So now we'll come in and start modifying our program. The first thing that we wanted to do was change the power speed at which it moves. So if I mouse over the bottom left portion of this function, it again changes into the wiring tool, indicating that a modifier can be wired into that portion, which is the power. If I right-click, a menu comes up, and I can go to Create Constant. Right-click Create Constant adds a constant value, an integer, to my block diagram, and in this case it indicates that the default is 75. I can actually now type in 25 and hit Enter, and that changed it from the default 75 to now running at 25. Second, I will mouse over the top middle of the motor move function, and there it shows the wiring tool and it indicates that I can change which motors are actually being run. Again, I will right-click and create constant. Right-click, create constant, which generates this constant, which allows me to select which motors are actually being controlled in this instance. Here I'm going to use the drop-down and I'm going to select the Lego port A, meaning the first motor. If I wanted to run multiple motors simultaneously, I could add them using this drop-down arrow or delete them using the up arrow. As we said, we were going to not only wire the port A into the motor move, but also into the motor brake. By hovering over a wire, you can see that it changes into the wiring tool, which allows me to use one wire to connect to multiple points on my program. If I single click and then move the mouse over to the exact same point on the brake, I can single click again, and now they are all connected together. Finally, for this first portion of the code, I'm going to right-click on the time. It says the default is 1 second. If I right-click there, again, right-click, create constant. That adds a number to the block diagram that I can change from the default of 1 to say a new number, value 2. If I select the entire code by clicking and dragging a box around it, I can then hit Control-C, or Apple-C on a Mac, click elsewhere in the block diagram, and paste it with Control-V. I've now duplicated that first set of code identically in another location on my program. Right now, these need to be connected together to indicate that first we want to move motor A, and then second we want us to do the second part of the program. To do so, just like we wired the first part together, I will put the mouse in the top right of this brake and connect it to the top left of the motors on. A single click starts the wiring. When I get to the destination, I single click again and it creates this wire. Since I wanted to modify it to not move port A but to move port D, I will use this drop down to select port D. And then finally, I'll modify this from 2 seconds by double clicking, typing in 3, hitting enter. Now I've modified it to go for 3 seconds. So, in summary, turning motor on connected to port A on at power 25 for 2 seconds, stopping it, and then immediately turning motor D on for 3 seconds. Let's see if this indeed is how the code operates. Here's motor A and motor D. I will hit the run button in the top right, and we should see it